Question 23. A gardener bought a bag of for potassium nitrate and a bag of ammonium sulfate. Yeah, so ammonium sulfate, you need to know that this is an ammonium salt. Okay, ammonium salt to be used as fertilizer. Forgot to label the bags. Which of the following reagents would enable him to distinguish between the two chemicals? So try to recall any reaction that involve ammonium salt. So you should know that ammonium salt plus alkali, you should get ammonia, water, and salt. Whereas alkali doesn't react with potassium nitrate. There is no reaction between nitrate and alkali. Yeah, so the reagent would enable him to distinguish would be calcium hydroxide, because calcium hydroxide is an alkali. Number 24. Which element in group 7 has a melting point below room temperature? Means at room temperature, what would be the state? Melting point below room temperature. At room temperature, that means room temperature is above the melting point, so it is liquid. But a boiling point below room temperature, meaning that at room temperature would be below the melting point, which means that at room temperature it is a liquid. So which group 7 element is a liquid at room temperature? Which is bromine. Okay. Number 25. Chromium is more reactive than iron. So chromium more reactive than iron, and tin is less reactive than iron. So tin. Right. Iron objects are coated with a layer of chromium. So remember, a less reactive metal is coated with a more reactive metal, which means that the more reactive metal will corrode in place of the less reactive metal. So which means sacrificial protection. So it's either A or B. How about the tin? It is also coated with tin. So if it is coated with tin, but since the tin is less reactive than iron, so tin will not provide any sacrificial protection to the iron. Instead, the function of tin in that case would be to act as a barrier to the air as well as water. That means prevent the iron from coming into contact with air as well as water. So it is B. So only a more reactive metal can provide sacrificial protection to a less reactive metal, like in this case chromium to iron. Number 26. Correctly compares high carbon steels and low carbon steel. High carbon steel and low carbon steel. So you need to recall from your metals chapter, low carbon steel basically is mild steel. So high carbon steel would be substances like knife or hammer. Okay, so they are all strong and brittle. High carbon steel. Okay, whereas for low carbon steel would be like car body. Okay, this one is malleable. Okay, malleable, that means more easily shaped. So the answer is B. Number 27. 2 pieces of aluminium foil are used for the following experiment. Dip the aluminium foil into copper 2 sulfate. Aluminium foil, copper 2 sulfate. So this one looks like it's a metal displacement reaction. Aluminium, copper. Aluminium is more reactive than copper. No visible change. That means no displacement reaction occur. Why? No displacement reaction. So that means there must be something on the aluminium foil. Then experiment 2, dip the aluminum foil into some concentrated. So you have aluminum foil into some concentrated HCl. Then after that, after it has already dipped into the concentrated hydrochloric acid, this aluminum foil will be dipped into copper 2 sulfate. Same. Then after that, a pink coating, which means that this must be the copper, because copper is pink or brown. Okay, a pure copper is pink. So you have got a pink coating forms quickly on the foil. So that means something must happen here. So this one, this concentrated hydrochloric acid must have reacted with the substance on the aluminum foil. So which suggestion about concentrated hydrochloric acid can be used to explain the above observation? B. It dissolves the protective layer of oxide. What oxide is that? Aluminum oxide. So remember, aluminum oxide is insoluble. So it would protect. It would provide protection. It would prevent the copper 2 sulfate from coming into contact with the aluminum. So it's aluminum oxide. This protective layer of oxide would be the aluminum oxide. So the aluminum oxide will react with concentrated hydrochloric acid. Because aluminum oxide is an amphoteric oxide, so it will react with hydrochloric acid to form salt and water. 28. You have metal M is placed between zinc and iron in the reactivity series. So you have zinc, you have M, you have iron. Which is the likely property of metal M? Likely property of metal M, it can be extracted by reduction from its ore. So remember, zinc and below. Okay, in the reactivity series, zinc and below, they can be extracted by reduction of metal ore. Zinc and below. Okay. Okay, how about this question? Iron filings. So what happens to the oil level at X? So you know that these iron filings left for a week. Iron filings will fill with gas P. Okay, it is filled with gas P. The taps are closed and the apparatus is left for a week. So that means there will be gas P here. There will be gas P. So this iron filing will. So you can see that the oil level rises or falls. So this iron filing will rust. So that means rusting, it needs oxygen as well as water. So it would use up the oxygen and the water vapor inside here. Okay. So your gas P must be damp oxygen. Okay, and then the oil level at X will fall. Why? Because when the oxygen here is being used up, the pressure here will decrease. When the pressure here will decrease, the outside pressure will push this water level down, because over here less pressure, more pressure. So the air pressure outside will push the oil level here down, and then this level will come up. Because at first it is same. At first the oil level is the same. After that, when the oxygen here is being used up, then the air pressure here would decrease, and the air pressure outside, which is the same as before, so it will push it down. Number 30. What were these colored substances? Now you have chlorine, potassium bromide. So straight away you can see that halogen, halogen. So this is a halogen displacement reaction. Halogen displacement reaction. Okay, so what will happen? Chlorine. So what happens here? It's chlorine plus potassium bromide. Which one is more reactive, chlorine or bromine? Chlorine is more reactive. So the bromine will be displaced, KCl. So what is left here would be bromine, which is reddish brown. So this bromine is reddish brown. So at P must be reddish brown. Okay, it is a vapor. Bromine is a liquid at room temperature, but in this case, it is being heated here. So over here will be hot. That's why you have a red-brown vapor. Then how about at Q? Okay, how about here? What will happen? So you have a lot of bromine vapor here. Okay, Br2, and then potassium iodide. So what will happen is bromine is more reactive than iodine. So bromine displaces iodine from potassium iodide. So you get something like that. Now over here is being heated. So which means that over here will be quite hot. So this iodine would be the iodine vapor. So this one would be the iodine vapor, which is basically purple. That explains this part. Then how about here? Here would be less hot already because it is further away from the source of heat. So which means that this that means at R, the iodine will turn solid. So this would be the iodine solid, which is actually purplish black. Okay, so the best answer is black solid. So therefore the answer is C. Actually for this question, you know what is at P, you know the answer already. No need to look at Q and R. I'm explaining it for the sake of explaining it. 31. Results of reacting 1 gram of magnesium granule with an excess of acid. So you have your magnesium, you have your acid. So what do you get? Hydrogen. Now excess of acid, which means that this one must be your limiting reactant. So you have 1 gram of your limiting reactant. Now remember, the amount of limiting reactant determines the amount of product. Very important, this thing. From speed of reaction chapter, you need to know amount of limiting reactant. Amount means mass or the mole. Amount of limiting reactant determines amount of product. So this amount of product can be the volume of the gas, if the gas is the product, or it can be the mass, can be the mole of the product. So in this case would be the volume of the product. So you can see that if you want to produce a curve Z, you have to look at two things. The height of the graph. The height of the graph is roughly half. So which means that for Z would be 0.5 gram, around 0.5 gram. Looks like it is half. The height here is half of the height here. Okay, so 0.5 gram of magnesium. Then how about, so this would be the height, number 1. Number 2, the gradient. Which gradient is steeper? This gradient is steeper, which means that the temperature or the temperature is higher or the concentration is higher. So if you look at it, 40 degrees Celsius now must be 50 and then 0.5 gram. The answer is C. So remember, look at two things. Look at two things are the height of the graph as well as the gradient of the graph. Height of the graph is determined by the amount of limiting reactant. The gradient of the graph basically is the speed of reaction, which is determined by factors such as concentration, temperature, the pressure, the particle size. Okay, Yeah. This one is determined by the amount of limiting reactant. So whenever there is speed of reaction question that involves graph, you look at these two things. Okay, energy change for the reaction between hydrogen and the halogen. Okay, so the diagram shows that the reaction are, so in this case is the energy of the product. The energy of the product is lesser than the energy of the reactant. So that means energy must be given out to the surrounding. Okay, so from here you know that energy must be given out to the surrounding, which is exothermic. Now how about chlorine and iodine? The energy change for the reaction between hydrogen and what is more than that for hydrogen and bromine. Now hydrogen and chlorine is more. Why? Because chlorine is a more reactive halogen compared to bromine. So if you react hydrogen with a more reactive halogen, then more heat would be given out to the surrounding. Yeah, so the answer is A. This question, what was the average rate of reaction? So the average rate of reaction would be the volume divided by the time. Rate of reaction or speed of reaction must be per time. The denominator must be time. So you have the time. In this case, the numerator would be the volume of hydrogen gas. So in this case, you just need to look at the gradient, which is read across 32 and then 40, which is 0.8. The answer is A. Which two reaction would this apparatus be suitable? This is collecting gas, so the reaction must produce gas. So gas must be a product here and here. So the answer is 2 and 4. Calcium metal added to dilute hydrochloric acid. Reaction is observed to be faster after 60 seconds than after only 10 seconds. So the answer is D. Heat is produced in the reaction and increases the rate. So why is it over 60 seconds? Because more heat is produced over a longer period of time. More heat is produced over a longer period of time. Platinum catalyzes the reaction. Okay, which statement are not true about the reaction? More sulfur trioxide is formed when more platinum is used. Now the amount of platinum does not affect the amount of product. Okay, catalysts only increase the rate of reaction or the speed of the reaction. It doesn't affect the amount of the product. So one, okay, not true. So one is not true. How about when platinum is present, the time taken to complete the reaction increases. It should be decreases because it makes the reaction faster. When the reaction is complete, the platinum catalyst gains mass. No, the mass doesn't change. Basically, what changes is the physical appearance. The physical appearance of the catalyst will change. So for example, granule may become small pieces, may become powdery. Yeah, so physical appearance of the catalyst will change. Other than that, nothing will change. So the answer is A. Which statement is correct? Okay, C is correct. Why Cl2 can oxidize Br minus? So Cl2. Br minus would be, for example, KBr, because KBr consists of K plus and Br minus. Okay, so if you write like this, it would be clearer. Again, this is halogen displacement reaction. Chlorine is more reactive than bromine. So what you get is Br2 and KCl. So let's look at it. What will happen? KCl again consists of K plus and Cl minus. So Cl2 can oxidize Br minus. Is Br minus oxidized? Br minus become Br2. Yes, this is oxidized. Yeah, so that's it. You know why is it oxidized, right? Oxidation state -1, oxidation state 0, increase in oxidation state, so it's an oxidation. Okay, 38 does not represent a redox reaction. BaSO4, so you can split it into Ba2 plus SO4 2 minus. So you can see that the oxidation state doesn't change at all, so it is not a redox reaction. A. Redox reaction, there must be reduction, there must be oxidation. In this case, oxidation states do not change at all. So no reduction, no oxidation. Okay, next question. A redox reaction. Which statements are true? So if you look at it, you can split it into Fe3 plus Cl minus. This one you can split it into Fe2 plus Cl minus. Fe2 plus Cl minus. So Fe3 plus to 2 plus, it's reduced. Okay, I think my red pen is running out of ink. Let me change first. Okay, so it is reduced. So when this substance is reduced, this one must be a reducing agent, correct? Iron 3 ions gains electron. Yeah, Fe3 plus to become Fe2 plus, you have to gain electrons, correct? How about the color of the solution changes from, this one is actually reddish brown. This one is green. Okay, changes from yellow, reddish brown and yellow, they are quite close. This one is green, green and pale green, also quite close. So it is correct, A. Ammonia is produced by the Haber process. Which statement is or are correct? First thing is, each hydrogen molecule, H2, reacts with 3 nitrogen molecules to form 2 molecules of ammonia. Is this correct? It's not even balanced. Actually, these 3 should go here. So the first statement is wrong. Hydrogen for the process can be obtained by the fractional distillation of A. A doesn't have any nitrogen. A has some argon, some water vapor, but there is no hydrogen. The hydrogen used, it is from the cracking of petroleum. Cracking of petroleum, that is where you get the hydrogen. Okay, so this statement is wrong. And only ammonia liquefies at it has a low boiling point than the unreacted. This is also wrong as well. So the answer is none of the above. D. Okay, so you can refer to the Haber process chapter and read more about it. Okay, with that, that is 2017 PHSS mid-year exam paper. Remember to do all the corrections, write down, and if necessary, refer to the mind maps or refer to the textbook to read more about the chapters. Thank you. Bye-bye.